Hello students, today we will be starting a new chapter which, as you can see, is called Trigonometry, or in short forms we just call it Trigo, or sometimes even just Trig, because obviously saying trigonometry every single time does not make any sense. This is one of the newest chapters you will be studying this year. It is a completely fresh concept, so we will start from the very basics and slowly build our way into some more detailed problems. Trigonometry, in its most basic understanding or definition, is simply the relationship between angles of a triangle and the sides of a triangle. And as far as this year is concerned, we will be dealing with the angles of a right-angled triangle with the sides of a right-angled triangle, and the relationship between these angles and the sides. So, to understand the basic concept of trigonometry this year, let us take a simple right-angled triangle. So let's say I have a right-angled triangle. I name it A, B, C, with clearly angle B being your 90 degrees. So what trigonometry will do is, generally not with angle B because it's a 90-degree angle, but with angle A and angle C, it will relate all of the sides. How? Let's say we start with angle C. Now if I look at this triangle, I can think of BC as the base of the triangle. I can think of AB as the perpendicular of the triangle. And obviously we know that AC is nothing but the hypotenuse of the triangle. We will keep these terms in mind and then look at what trigonometry does with them. Now, this year you are going to learn 6 functions or operations, or basically terms, that define trigonometry for the rest of your life. Starting with sine. Now when I say sine C, this means sine of angle C. So sine of angle C. It is defined as perpendicular, which I am going to refer to as simply P, divided by hypotenuse, which I am going to call H, or in this particular triangle, sine C is equal to AB upon AC. Next, we have what is known as cos C. Now cos is actually a short form for cosine, but nobody actually calls it that because again it's very long. We simply call it cos. Sine C is perpendicular upon hypotenuse. Cos C is base upon hypotenuse. So base, which I'll call B, upon hypotenuse, or again in this particular case BC upon AC. And finally, we have what is known as tan C. Tan is actually short of tangent, but we just call it tan. Now tan C is actually perpendicular upon base. Right? So in this case, tan C is equal to AB upon BC. These are your 3 standard trigonometric functions or operations, or whatever you want to call them: sine, cos and tan. Now you have 3 more which are simply the inverses of these 3. So while you have sine C, you have something known as cosec C. And cosec C is simply H upon P, or as I said, inverse of sine C. You have sec C, which is nothing but H upon B, or inverse of cos C. And you have cot C, which stands for cotangent of C, so cotangent, and this will be base upon perpendicular, or inverse of tan C. So the full forms of this is known as secant, this is known as cosecant, and this is known as cotangent. But again, that is not critical. All you need to remember, sine is P by H, cos B by H, tan P by B, cosec H by P, or inverse of sine. So that's why I've written them like this. Cosec is connected to sine, sec is connected to cos, and cot is connected to tan. Never confuse what they are the inverse of. If you keep these things in mind, this is the most basic part of the chapter and has to be clear. Now we will do an example in which, rather than just having random A, B, B, C, A, C, we're going to look at some value-based questions and also look at what happens if I take sine C as opposed to sine A as opposed to sine C. So we'll look at that and see what we get. So now let's look at a question where, using our knowledge of the trigonometric functions, we create our triangle and then further solve some problems. So let's say we're told that in a triangle ABC, in which angle B is 90 degrees, sine A is equal to 3 by 5. And they then tell you, creating the triangle, they will not tell you that, but they will say find cos A, cot A, and sine C. Now we will look at how to do sine C after we create the triangle. Now we'll create our triangle. So of course we were given that angle B is 90 degrees. From how we learnt trigonometry, we always kept our angle at the bottom. So we'll say this is A, which clearly means this is C. Now if sine A is 3 by 5, that clearly means that perpendicular upon hypotenuse is 3 by 5. So let's assume that BC is equal to 3K. K is just because it doesn't have to be 3 and 5. It can also be 6 and 10 or 9 and 15 and so on and so forth, because this division. If BC is 3 by 5 is 3K, AC will be 5K. So this is all the information currently available to us. Now we look at the question. Question says cos A. Now cos A, we remember, is base upon hypotenuse. But I don't know my base. How can we find it? Of course, it's a right angle triangle. We know two sides, which means using Pythagoras theorem, I can find AB. So of course, we know that AB square plus BC square is equal to AC square, which will mean that AB square is equal to AC square minus BC square, which is nothing but AB square is equal to 5K square minus 3K square. And of course, we've been doing Pythagoras triangles for a very long time. We know this is our standard 3, 4, 5 triangle. So this will of course come out to be 16K square, which will mean that AB is nothing but the square root of 16K square, which will be 4K. Not plus minus because it's a length. How can length ever be negative? So now I know that AB is 4K. So great, I know all three sides of my triangle. Now I'll look at cos A. Cos A is base upon hypotenuse, AB upon AC, which will be equal to 4K upon 5K, nothing but 4 by 5. Similarly, cot A, I'm going to do this directly now. We remembered cot A, how I keep track of it, it's inverse of tan. Tan is P by B, so this is B by P. 4K upon 3K, 4 by 3. Now we come to the interesting one, which is sin C. Now obviously sin C will not be the same as sin A. Then what is the point of A and C? So if you think about it, if I tilt my head and look at this triangle, as far as C is concerned, AB is its perpendicular, BC is its base, and hypotenuse is still nothing but AC. So we know that sin is perpendicular upon hypotenuse, which means for C, sin C will be AB upon AC, because AB is its perpendicular, which will again be nothing but 4K upon 5K or 4 upon 5. Now you may notice that cos A and sin A are equal to each other. This is actually a very important property that we will look at a little bit later in the chapter. But for now, what you need to remember is when I am asked about a trigonometric function, I must know what angle I am talking about, and for that angle, what is perpendicular and what is base. Sometimes you can remember it as perpendicular also means opposite. So obviously for sin A, perpendicular was BC, which is opposite to A. And cos is base upon hypotenuse. Base can also be thought of as same side, because cos A is AB upon AC, which is the same side with A. But just keep track of it, visualize and solve it from there. So this is of course one of the most basic types of questions where you're just given one trigonometric value and asked to find the rest of them. Let's actually look at some standard values that you will be expected to remember and how to apply those in a question. So now we are going to look at a table in which, as you can see, I have written all 6 of my trigonometric functions and I have written 5 very specific angles: 0, 30, 45, 60 and 90. You are expected to remember each trigonometric function value for each of these angles. Now while that might initially look very daunting, the reason I am filling in the table with you is when you learn how to fill the table in, you also learn how to remember the values. In fact, if you just remember the values of sine, you can actually get all of the others from that itself. So let's see how. Now sine 0 is equal to 0. Sine 30 is equal to 1 by 2 or half. Sine 45 is equal to 1 upon root 2. Sine 60 is equal to root 3 upon 2, and sine 90 is equal to 1. Now, as I said, if you know the values of sine, you can fill in the rest of the table. Let's start with cos. Cos is filled in the opposite order of sine, meaning cos 0 is the same as sine 90, 1. Cos 30 is the same as sine 60, root 3 by 2. cos 45 is in fact the same as sin 45 because it's right in the middle, 1 by root 2. Cos 60 is the same as sin 30, 1 by 2. And cos 90 is the same as cos 0, sin 0, which is 0. So cos is reverse of sine. Now coming to tan. Tan, and we will look at this later in terms of an identity, is of course nothing but sine upon cos. So if you think about it, this is P by H, this is B by H, this is P by B. If I do P by H divided by B by H, the H's will just get cancelled in the denominators. I'll be left with P by B. So tan 0, sine upon cos, 0 divided by 1, 0. Tan 30, 1 by 2 divided by root 3 by 2, again denominators get cut, 1 by root 3. Tan 45, 1 by root 2 divided by 1 by root 2, same number, 1. Tan 60, root 3 by 2 divided by 1 by 2. 2 and 2 get cut, root 3. And tan 90 is 1 divided by 0 or nothing but not defined. Now tan, another property of tan you can see is that this is 0, this is 1 by 0. This is 1 by root 3, this is root 3, and of course right at the center you have 1. So you can even remember it like that. It goes reciprocal. Now we know by definition cosec is inverse of sine. So 1 by 0 not defined. 1 upon 1 by 2 or just direct reciprocal 2. Direct reciprocal root 2. 2 by root 3, 1 upon 1, just 1. Sec is direct reciprocal of cos, or like cos was the reverse of sine, sec is the reverse of cosec, whichever way you want to do it. Let's do it with cos. Reciprocal, 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 and 1 by 0 or not defined. Cot is the inverse of tan or cos upon sine, however you want to think about it. So again, not defined, root 3, 1, 1 by root 3, and now 1 upon not defined or 1 upon 0, just get back to 0. In fact, cot is also nothing but tan in reverse. So as I said, if you can remember your sine values, you can fill up the table yourself without remembering the others. Over time, you will naturally remember these values, but for initially, just remember sine and then remember, okay, cos was reverse of sine, tan is sine upon cos, and of course, these are just inverse. So keep that in mind, then you'll get these values. So a little bit later, we're going to look at some questions where we need to know these values to solve the answer. But before we do those questions, let's start doing what are known as identities in trigonometry. So as I said, we are now going to look at some identities in trigonometry. Now what does that mean? So you remember in algebra, we've studied identities. A plus b whole square is a square plus 2ab plus b square. A minus b whole square is a square minus 2ab plus b square. We used to learn these things because they are always true, and we then apply them in questions to simplify our problems. Trigonometry also has identities. It also has some things that are always true and always happen. Starting with what are known as the complementary identities or complementary functions. Now, complementary identities if you remember from geometry, complementary means two angles that add up to 90 degrees. And that is exactly what we're going to be looking at here. So let's draw our triangle again. We have our A, B, C with B equal to 90. Now recall in the first video, we found that sine A and cos C, or actually we did cos A and sine C are equal to each other. This will be explained in complementary identities. The complementary identities state that if I have some angle theta, then sine 90 minus theta is simply equal to cos theta, and the vice versa is also true. Cos 90 minus theta is equal to sine theta. So cos and sine are paired. Next, tan 90 minus theta is equal to cot theta, and cot 90 minus theta is equal to tan theta. And finally, cosec 90 minus theta is equal to sec theta, and of course sec 90 minus theta is equal to cosec theta. Now you might be asking, what does this mean? What is the purpose behind it? What are we saying here? We're saying that if I represent my angle as 90 minus theta, rather than calculating it as a sine value, I calculate it as a cos value. Let's do an example. Sine 30 degrees. I rewrite it as sine 90 minus 60, because of course 30 is nothing but 90 minus 60. Now sine 90 minus 60, sine 90 minus theta, I replace it with cos theta or cos 60. And if you remember from our table, sine 30 is half, cos 60 is also half. So there it is equal. Here we can also see that it's equal. This is a very important property because later you will get questions where only by applying this you get to the answer. Now the explanation for this is very straightforward. Let's say that angle A is theta. Now of course this is a right angle triangle, which means A plus C must be equal to 90 degrees. A is theta, C is clearly 90 minus theta. And so A is theta, C is 90 minus theta. We know sine 90 minus theta is equal to AB upon AC. Cos theta is also AB upon AC. And like that, all of them. Tan 90 minus theta will be AB upon BC, which is cot theta, base upon perpendicular. So like this. So these three relationships, I say three because these are just opposites of each other. Just remember, sine and cos, tan and cot, cosec and sec. After we do our next set of identities, we're going to look at questions where we'll apply this, we'll apply the values from our table, and of course, apply the new identities. Now, we're going to look at the three major identities of this year, which are sine square theta, which just means sine theta whole squared. We write it like this for ease of use. This just means you take sine theta and you square it. Sine square theta plus cos square theta is equal to 1. First identity. second identity. Sec square theta is equal to tan square theta plus 1, and sec tan cosec square theta is equal to cot square theta plus 1. So these two can be remembered like that. Remember, sec square theta is equal to tan square theta plus 1. Then just change sec to cosec, tan to cot, and you get the second one. First one, of course, sin square theta plus cos square theta is equal to 1. Now I am going to show you, for easing your understanding of this, the derivation of the first identity. It's actually very straightforward and it's quite interesting as well. After that, you can try for yourself deriving these two. Let's go back to our triangle. Once again, I've drawn my triangle, named it ABC, and I've taken angle A to be theta. So let's actually find the value of sin square theta plus cos square theta. Now, of course, sin theta here will be BC upon AC, which means sin square theta will be BC upon AC whole square. As I said, this is just the square of sin theta. Cos theta will be AB upon AC. So clearly cos square theta will be AB upon AC whole square. Now if I square this, I clearly get BC square upon AC square plus AB square upon AC square. Now this is the same LCM, so I don't need to do anything, same denominator. This will automatically just turn into BC square plus AB square upon AC square. And what is BC square plus AB square? Right angle triangle Pythagoras theorem, it's AC square. AC square upon AC square, which is of course nothing but 1. So clearly sin square theta plus cos square theta is equal to 1. So just like this, you can prove these two as well. In these, expand the RHS and see what you get. Now, you might be asking, what is the need for this? If I know sin theta and cos theta, I don't need this, I can just put it into the values. So what if you don't know the values of sin and cos? Then these identities come into play, along with our complementary identities, along with sometimes values of our functions.